Alright, so we're going to talk about how to sketch a graph of this function without using a calculator and using the concept of multiplicity. So multiplicity, remember multiplicity means, first of all, I've got two linear factors that I see here, but one of them shows up 3 times. That 0, whatever comes from this right here, is going to have a multiplicity 3. And we'll talk about what that means in a second. So first of all, notice that it's a negative leading coefficient, and this total sum of the degrees, the total number of x's, if you multiply this out, would be 4. So it's degree 4, and it's an odd leading coefficient. Odd leading coefficient, LC. So odd leading coefficient means that it's going to go down from left to right. So think about your most basic odd function, polynomial function with a negative leading coefficient is just y equals negative x, which does this. That's what y equals negative x does. So our graph is going to do the same thing. It's going to go down to the right as x goes to infinity, and it's going to go up on the left as x goes to negative infinity. It's going positively. Okay, so that's the first thing to do. And again, that came from these two things right here, negative, and the, whoops, I lied. It's degree 4. My bad. I was looking only at the 3. It's actually degree 4. 3 plus 1 is 4. So it doesn't go down on the, it doesn't go up on the left. It goes, so my sample is y equals negative x squared. Y equals negative x squared is this. It goes down on both sides. So that's the model that I'm thinking about in my head when I look at the leading coefficient and the degree. I know it goes down on both sides. As x goes to negative infinity, y, or the function value f of x, goes to negative infinity. As x goes to positive infinity, as I go further to the right, the graph is going to go down to the right. Okay? That's the first thing. The second thing to do is to look at the points. My points are, my zeros, I'm sorry. My zeros are going to be, right here you can see the 0. If I set that equal to 0, I get x equals 1. So there's one of my zeros.
Oh, yeah, because that's
and my other 0 comes from here, and if I set that equal to 0, notice I don't have to worry about the negatives, that's on the outside. If I set that equal to 0, I'll get x equals negative 7 over 2. So it's negative 3.5. Right there, negative 7 over 2 is negative 3.5. So now what I do is put all of this stuff together with the fact that multiplicity tells me whether the graph goes through it or bounces off it. Since the multiplicity means how many zeros there were of each 0. There was actually 3 of the negative 7/2 zeros. There was actually 3 of them, because this is like 2x minus 7, sorry, plus 7 times 2x plus 7 times 2x plus 7. That's really what you had there. So you had 3 of the same zeros. So you have 3 of the same zeros. So that means that it's going to go through at this point. So you know it's going to go through, but since there's 3, do you remember what y equals x cubed looked like? Y equals x cubed, well, let me just draw it right here. It did this. It went through at 0, but it inflected. It turned, kind of went the other direction. You'll learn more about that when you get to calculus. So that's what's going to happen when you have a multiplicity 3. It's going to go through, but it's going to inflect. So I know it's down. It's going down this way, so I'm just going to draw it like this. That's what's going to happen at negative 3.5. Negative 7/2 is going to inflect right there. And then what else is happening? Well, the multiplicity at 1, right here, is 1. There's only one of the zeros. X equals, or x minus 1 equals 0. I set that equal to 0, and I get x equals 1. And so it's going to go through. Now, they want you to sketch the graph. They don't really care that you're doing it exactly. They just want to know the rough behavior of the graph. So it's got to come back at some point. That's what's going to happen. It's going to come back because I know it's going to end up going down. It's got to, at some point you're going to have a maximum up here somewhere, and it's going to come down and go through the x-axis again right there. So that's the general shape of your graph.
Yeah.